Okay, hi everyone. So here I am trying to catch us up on maths while I'm going to be away, and I'm very sorry about how this is going to go. I have to use this little pen thing to draw, and I'm just terrible at it. So we'll kind of see how it goes, and hopefully you'll be able to understand what I'm doing. First thing I kind of have to really apologise for is that I couldn't get the software that I need to use to work on my laptop, which is where my calculator software is. So you will probably at some stage have to watch another video where I go through what you need to run on the calculator. But for the moment, let's get started on our second topic for the year, even before we've kind of finished the first one, and that is further differentiation and application. So what we're looking at with here is pretty much we're going to go through exponentials, logs, and we're going to go through some of the applications of calculus. So the first big application that we have is what's called, sorry, I just need to change my pen over, is what we call kinematics. And kinematics is quite literally just another word for movement. Okay, and when we're talking about movement, there's three major things that we kind of want to look at. The first one is what we call position, the second one is velocity, and the third one is acceleration. Okay, so when we talk about position, there's another word that we use for position, and that is displacement. Okay, so when we're talking about the displacement of something, we're just meaning whereabouts it sits on a graph or in a function. Okay, and the three things you have to know about position is that your position is equal to 0, that means you're at the origin or at your starting point. If your position is greater than 0, it means that you're at the right of your origin, and if your position is less than 0, that means you're at the left of your origin. Hang on. Okay, so so then if x is less than 0, that means you're at the left of your origin. Okay, sorry, I just have to stop for a second. So the main thing is that when we're looking at position, we use this. Okay, we use this notation, and that is S of t. So S of t tells you S of t always means position, and S of t, in terms of derivatives in calculus, S of t is equal to your f of x function, and so that's like your original starting function when we're looking at kinematics. Okay, the next most important thing in kinematics is this idea of velocity. Okay, and velocity is the change in your position with respect to time. Okay, and velocity is quite similar to when we're talking about speed. Okay, but speed, for example, doesn't have a direction. Speed only has what we call a magnitude. So you can only drive at 10 kilometers per hour. You can't drive at negative 10 kilometers per hour. So that's why we get this idea of velocity in, so we can incorporate the direction of movement as well as just the magnitude of movement. Alright, so when velocity is equal to 0, that means that your object is at rest. When your velocity is greater than 0, that means that you're moving to the right. When your velocity is less than 0, that means you're moving towards the left. Okay, so you're either at a standstill, you're moving to the right, or you're moving to the left. Okay, and velocity is the rate of change of displacement with respect to time, which quite literally just means that it's the derivative of your displacement. Okay, so velocity is the derivative of your displacement. So like I said before, if displacement is f of x, then velocity would be like I said, I'm terrible at using this, f dash of x. Okay, so it's your first derivative. So v of t is equal to s dash of t. Oops, sorry, gone too far, back up. Alright, and the last thing is acceleration. So acceleration measures the rate of change of your velocity with respect to time. So again, if velocity is the change in the displacement, acceleration is your change in your velocity. Okay, so to find acceleration, again, if velocity was f dash of x, then your displacement would be f double dash of x, so your second derivative. Okay, and if your acceleration is equal to 0, you've kind of got three things that could be happening. You could be moving just at a completely constant velocity. So say if you're traveling at 10 kilometers per hour, you're neither increasing your speed nor decreasing your speed, so your acceleration is 0. You could also reach, say, a maximum velocity and then be changing direction. So if you've reached a maximum velocity or a minimum velocity, again, you're not accelerating because you're changing directions. Okay. If your acceleration is greater than 0, your velocity is increasing, and if your velocity is less than 0, your velocity is decreasing. Okay. And here's some important notes that you guys need. And again, for this test, you're going to have a cheat sheet, and so I would recommend having like these kind of things in here. Okay, so your initial conditions are that it's always where your time is equal to 0, so s of 0, v of 0, a of 0. The second one is that your object changes direction when your velocity has the same sign. Your speed increases when velocity and acceleration have the same sign. Your speed decreases when velocity and acceleration have opposite signs. And the total distance is the sum of all the distances that you've travelled in the opposite direction. Okay, I've been advised that I should keep these to around about 7 minutes, so I'm going to stop that for now and then I'll do another video with some of the examples.